Hi, this is Anushri Saran and this is my final project. So aim of the project is to implement a digit detection and recognition system using CNN on SVHN. So the whole idea is to implement and train a model that would identify digits. Next step was to implement an object detection system to detect numbers in real-world images outside the dataset. So the dataset that I used was SVHN. So it is a 10 class, one for each digit. That is label 9 for digit 9 and 10 for digit 0. There are total 73k digits for training and 23k digits for testing. So there are two formats in the dataset. One had original images with bounding box available for each digit, so multiple digits may be present in a single image. The second was MNIST like 32 cross 32 cropped images having label for single character in each image. I use the format one for creation of my dataset. So these are the data characteristics. We can see the labels from 1 to 10. And the normalization technique that was used for pre-processing was we had the original data, then I shifted it to zero center by subtracting it by mean, and then normalized it by dividing it by standard deviation. So the challenges I faced while creating the data set was extracting the digits from format 1 because the quantity of images were too large. Like in the end, the data set was close to 80 gig if I used 24 cross 224 for BGG16. And my laptop 16 GB RAM would run out of memory while normalizing these images. So then I had to move to another machine. So these are the two machine specs. One was my normal laptop, which had a RAM of 16 gig and Core i5. And the machine 2 specs, I had 32 GB RAM with a GeForce GTX 1060 GPU on i7. So these are the details of the algorithms that I implemented. So one was a custom 4-layer CNN model, then pre-trained VGG with 224 cross 224 image, and then custom VGG like with 32 cross 32 image size. Here are the details of my custom CNN model. It was a shallow 4-layer CNN model which gave a decent test accuracy of 87%. Then the VGG like, which was the algorithm that I used for the results, it gave me an accuracy of 92%. I'm gonna discuss the accuracy details later. So for object detection, I use a sliding window technique. So in an image, there was a window of 32 cross 32, which would slide over, and the step size were 4 to 8 pixels. After that, I used the image pyramid where the image was scaled, and then the sliding window would occur again. All these images were collected and then they were sent to the model for prediction. Here are the results. So you can see like my 4-layer model had a test accuracy of 87.6 and VGG16 like was the best, which had a test accuracy of 92.9. My pre-trained VGG16 somehow I did not get to converge it, so it had a very bad accuracy and a very high test loss. Here are the results of my algorithm. So if you look at the confusion matrix, we can see that the prediction is much better for labels 2 to 4 because of more training data, and they are kind of worst in case of 8. And accuracy of negative images, that is label 10, is pretty good. So for comparison and improvement, the sliding window object detection technique is nowhere close to YOLO's performance, and a region-based detector can bring significant improvement. And deeper classifier model like ResNet, larger feature size, and more training sample for some of the digits can increase accuracy. Thank you.